Okay, welcome to Unschooling Conversations. Today I am joined by Krish, and in this episode we are going to talk about unschooling maths. I'm Heidi Steel, former teacher and unschooling parent to 4 school-aged children who are happy living and learning as they go. I've been unschooling for 10 years and I blog regularly and organise coaching and mentoring services on unschooling, which you can find out more about at liveplaylearn.org. I'm also on Facebook at Live Play Learn, where I provide daily support and encouragement for unschooling families. So welcome to the podcast, Krish.
Hi.
Hi, would you like to introduce yourself?
Yeah, my name's Krish. I'm also an unschooling parent, but I think Alice, my wife, bears the brunt of most of the home education in our family. So I'm also a teacher. I'm a secondary maths teacher, but I'm a frustrated secondary maths teacher because I don't really like the curriculum or the system or the way things are done. So that's a little bit about me. I've had pretty much close to 20 years of experience in different schools, and I've taught in special needs schools, and we do things very differently at home, and I think you're going to find that out today.
Fabulous. So as you mentioned, actually, and I'm just going to put in a little, I can't think what it's called, little advert, because actually I have also done a podcast with your wife, Alice. It was actually the first podcast recording that I did, and we talked about, obviously we talked about unschooling, and we predominantly talked about unschooling teenagers, because your children are actually, I was going to say quite old. That doesn't, they're not old, but you know, they're old, aren't they? So could you just run through maybe how old your children are and how long they have been, home educated?
So our oldest is 19. His name's Elias. He's 19. We pulled him out of school well, actually, I mean, it was strange because we never did year 1 because we were out in Turkey. My wife and I teaching English, and so he never had year 1. He went into school in year 2 in this country when we came back from Turkey. And then in year 3, we just saw his kind of demeanor sort of really, I mean, he lost confidence, and for someone who's very bright and always asking questions, he kind of had his head down, and he went sort of very quiet, and his sort of spark went in year 3, partly because of the teacher, but just other things really, and so we just felt like it was really too young an age for them to lose interest in learning. And so we gave him the option of being pulled out and doing something in a different way, kind of realizing that whatever primary school he was going to end up in, it's going to be the same thing. So yeah, we took that decision, and then we've got Josiah, who's 18, and again, he did year 1, and that was it. And we kind of pull them all out. And then Noah's never been to school. He's now 15. He's not had any experience in school, and Zephin's 9, and he's never been to school either. So yeah, we've got 3 who are fairly close together, and then Zephin who's 9, where there's a gap. Yeah.
So you've been doing this in terms of home educating. This has been like a long-term thing. So you've got quite a lot of, I'm hoping you've got quite a lot of experience under your belt, and a lot that you will be able to share with us today. So we're really here to sort of talk about maths. It's something that is often seen as a key skill, like alongside literacy. But it's also something that I hear a lot of people feeling really nervous about because of their own sort of negative experiences of learning maths at school and feeling like they, failed, or they weren't very good at it, or they didn't understand it. It seems to come for a lot of people with those negative connotations. And I say that because I'm assuming that you are a lover of maths, and myself, it's actually something that I quite enjoyed at school, and I was relatively good at. So that's not an experience that I share, but that is something that we hear voiced a lot amongst parents, and particularly amongst parents who are educating their children at home and feeling the responsibility of having to do that. So we're often caught between this place of sort of recognizing the importance of the skill, but sort of lacking the confidence and the knowledge to be able to sort of help our children with it. And as is common in unschooling, we're looking for alternative ways of learning, ones that sort of move away from that, I'm going to fill you up with knowledge and I'm going to tell you how it's done, and sort of acknowledging that our children, like you say, they have a natural love of learning, like you were explaining a minute ago, and they are sort of active participants in their learning. So one of the things I wanted to ask you was, if children aren't explicitly taught maths, as they are in school, that's an explicit teaching, how are they going to learn all the stuff that they need to learn to operate as adults, with the mathematical knowledge that they are going to need? How do they do that?
That's a really good question. I mean, it's for me, it started when I was teaching maths, and over the years I was thinking, they've been in school for the best part of 11 years by the time they get to year 11, GCSE year 11. So they've had all this input in maths, and far too many just don't know how to go about solving a problem. So they might have spent ages learning how to add things and divide things and times things and so on. But when it comes to tackling questions, they just a lot of children just fall apart, and they sort of panic, and it's probably one of the only subjects that causes kind of fear and panic, whereas other subjects don't seem to do that. And I don't know why that is, but it's probably the way we approach things at school. But yeah, so going back, I was thinking there's got to be a different way of doing it, because they've had all this input and it's not really helping. So what is it that we kind of need to focus on? And I think one thing that I kind of observed when I was teaching secondary school is I could see there was a lack of play, because had children played more, and I'm not talking about reception, it's, the play kind of stops in year 1 and everything's too formalized. And why? Because, play cements their understanding. It goes from the real to the abstract, and they make their connections through play. And the moment you stop that and teachers kind of input things when they're not ready, they haven't got the play, creates the hooks for the abstract concepts to glue onto. And if they've missed out that play, they've got a less of a chance of understanding things than someone who's played a lot. So, maths shouldn't really be about kind of learning loads and loads of things and formula and procedures, which tends to be the focus in primary and secondary school. And so most people think that mathematics is, well, if you learn the formula and if you know the procedures, you'll be good at maths. Well, no, it doesn't mean you're going to be good at maths. And in fact, sometimes procedures can be so confusing because they're following a procedure that they don't really understand. So they're not really understanding what's going on. So yeah, I just think that it all, for most children, it became about, maths is about learning all the formula, and then it's kind of like a panic. What formula do I need to use for this? Rather than sort of thinking about the question and just trying to, you almost need to try and solve it from first principles without the formula. But there's I think it's to do with the fact that everything's examined, and there's this great pressure on teachers to follow the curriculum. To it's you're learning to do a test, and you're not learning maths as a pattern. Maths is not doing a GCSE, and maths is not about doing an A level. Mathematics is a kind of thinking. It's about exploring the world and trying to find solutions. And sometimes there are no formula for the thing that we're trying to find out. So you have to invent new maths, and mathematicians will tell you that. So maths is about looking at the world, and you have to play with it. Even when you're older, you have to play with it. And even now, if I'm trying to solve a maths problem, I'm drawing pictures. I'm still doing that. And I tell children to draw pictures and try and understand it, or get sort of props to try and understand what's going on. So, yeah, I think, I can't remember what the question was, but yeah, I think that's what's going wrong, that it's not becoming concrete because of this lack of play, and that play shouldn't stop. It should not stop. And so we've always, when we were home educated, or the children were learning at home, should I say, we didn't do very much formal maths, and if the maths came up, we talk about it, but not in a very informal way. We certainly didn't give them procedures and methods, and they kind of figured it out. There was nothing. Zephyr knows how to add up, and Zephyr knows how to multiply because he's kind of figured it out. So nothing was formally taught, but these things just come up. And they come up when you're baking, or Zephyr gets some pocket money, and fairly quickly he knows what he can afford to spend his money on and what he can't afford to spend his money on, or he learns how to save the money so that he can spend that money on the thing that he really wants. But it's the everyday things that they do. But it's not just that, is it? It's playing Lego. I mean, you don't have to have a math lesson, is it? Right? So just by playing Lego, you're learning how to count, because you need to follow those instructions if you are doing that to make that car or whatever you're trying to build. And so you're having to count the little pins, or what, I don't know what you call them.
I don't know what you call them either. I know what you mean.
Yeah, on the Lego. So, and also you're kind of like looking at 2D diagram, and then you're translating that into 3D. So there's all sorts of different things that are going on. And then when they create their own Lego, not following instructions, very often they're doing things that are symmetrical, aren't they? So they're learning symmetry anyway without having to formally kind of do a silly lesson on symmetry. So I think, that's why I say play is so important, because so much of what we learn, even as adults, is through play. And if we don't know how to do something, we find out, or we look on YouTube, or we play. Mm-hmm. We have to.
I'm so my background is actually in early years. That's where I sort of specialised. That's where I spent a lot of my teaching career, and I loved it. And a lot of the studying that I did, to be able to hold that teaching position was in play, and the importance of play and why it was important. And this idea that you've brought up, that it enables children to explore the world in a practical sense, concrete. They have items in front of them, like Lego, for example, that they pick up and they use and they experiment with, and if they're putting the bricks together and they've got a brick that's 4 by 2, and then they find 2 bricks that are 2 by 2 and they fit, then they've worked out that
yes,
they've worked
that's
something out.
the half of that.
Yeah. But if they choose the wrong brick and put it on and that doesn't work, no one's there to tell them they're wrong or to make them feel bad about it. They just take the brick off, chuck it away, and find the one that they and find the one that they need. And obviously, when our children are at home, they are able to continue that for as long as they need to. If that's what they still need to be doing to as their way of figuring something out. Well, like you say, even adults do it. Even adults draw pictures or grab equipment that they need to be able to physically see what they're doing. And if our children still need to be doing that when they're 13, 14 or 15, then they're able to. But it makes a difference to how they then are able to relate that into the abstract, because they've got this wealth of experience that they have acquired that they can then translate. I remember my son, so I've written down quite a lot of things about how my children use maths in every day. I wrote down Lego, but one of the things I wrote down was my son bought these tiny little magnetic balls, but he would sit and they're magnetic, so he'd make strings of them, and then he'd make pyramids, and he was just fiddling. He wasn't setting out, but he very quickly figured out things that mathematically I struggle with in the abstract, but he very quickly figured out sort of square numbers and cubed numbers and triangular numbers, just because he was sat there for days on end just playing with these this magnetic set. And it was really interesting from my point of view to look at that and say, oh, because he had it physically, it was so, like, even I could see, oh, that's how it works. Oh, I understand that now. But of course, like you say, he wasn't actually setting out to do mathematics. He was playing with the idea of numbers and how does this work and what does it look like, and it was just it wasn't we didn't sit and teach him that. It was just part of what he was doing that day.
Yeah, and I get, going on from that, I kind of feel like when we start to teach formally in year 1 and 2 and so on, right the way, so reception is really pretty much the only time they really get to play all the time. So then when it comes to year 1, everything's formalized, and then we've kind of interrupted that play, and that I just can't stress enough how important play is. So we've interrupted that, so we've shortcutted that, and almost you're creating a short circuit in the brain, because they haven't played and they haven't made the connections, and you're kind of like, as the teacher or whatever, whoever's teaching them is trying to do this input, but they've got no hook for the knowledge to be glued onto, because they haven't had the experience of play. So that's why it's so important. Like the sand pit in reception. Why does it have to stop in reception? Because what are they doing? Okay, they're pouring sand, but they realize that that I don't know, they might have cups in the sandpit, and that shape, that volume of sand fits in the cup, but when you plonk it on if it's not wet, it kind of collapses, but it's still the same volume. Or they could be pouring from one container to another and actually realizing that one container is bigger than the other container, or holds more or holds less. And all those things are really important, because when it comes to like later on talking about volume, they've got something to relate to. Now, why does it have to stop? I just don't understand. So, the way we our kids learn, because we didn't it was through conversations, but it was also, most of it was through play, but their play became more sophisticated as the years go on. So it's much, like by the time like Elias wanted to know how to split, he realized that hydrogen could be a fuel, and he wanted to split water into hydrogen and oxygen, and he actually made a machine that would do that. He actually split water into hydrogen and oxygen, and I can't remember, I don't know how he did it, but it was play. The whole thing was play. For a time he was kind of interested in rockets, so he made these rocket cars, but then I mean, this would concern parents, and we were kind of like okay about it as long as it was controlled. But he was kind of interested in explosives, because rockets and explosives kind of go together. So we made these rockets, and we made things that went up in the air, and then he made a kind of rocket, but it was controlled, and he put it under our trampoline, and it created a hole in our trampoline, by the way. But anyway, what's the point of this? The play became more sophisticated, so it goes from playing with sand and working out volumes to building Lego Technic, to making machines and tinkering, and then towards the end, this was in year 9, he's kind of like pulling apart an engine and figuring out what everything is, and so on. So but then why did we allow that? Because I wanted him to, we wanted him to discover and problem solve himself, rather than being told how to do things and what to do. And so those are the skills that you need. So I was fairly confident that, Elias and Josiah may need some GCSEs, but they'll all already have all the foundations that they need to then go and learn GCSE maths or whatever it is that they need to know. So, basically they had like up until year 9, and because they only went to school in year 10, they'd had everything was play based, very little for formal maths. So, but they understood things. They understood numbers, because they were kind of interested in money. And some of the other things that they did was kind of create little enterprises. So they would, I think one of the first things that one of Elias's first enterprises was making soap. So we got a soap kit. He realized he could sell it, but then he had to go and do some research and find a more cost-effective way of buying a whole block of soap and the perfume and everything. And then how much could he sell each soap bar for? And he was making a profit, and I can't remember. So initially we gave the initial investment and said, right, we're going to loan you this money, and then he made it back plus however much profit he made. So the maths comes into it when they are actually doing something for real. you don't have to, like, it's not a contrived SATs question or GCSE question, which are, by the way, some of them are completely ridiculous and unrealistic anyway. Yeah, so that's kind of the way we approach things. But yeah, play, and even if it's like, you may think something like Cluedo has no bearing on maths, but it does, because what they are learning is what's the word that I'm trying to look for?
I'm gonna plump for logic.
Logic, deduction.
Yeah.
In logic and deduction, right? And pretty much any game that you play has logic and deduction, and those are the other skills that you need to do maths, because you're always trying to you're finding the missing piece, right? And whether you, so if you're playing Cluedo or Guess Who or Mastermind or whatever it is, it's always about deduction. So then once they've got those skills, like solving equations or solving simultaneous equations, you can do that because you've already had those skills by playing these games. But I like games because games are great because they're almost like real life. You have to make decisions, and your decisions have consequences, and it could be the difference between losing and winning the game. But they learn so much through the process. So I'm a big fan of games.
Yeah, I've got a little list of games here of things that we are sort of popular in our house. But like you say, you can almost play sort of any sort of board game or any game at all, really, and it's developing those sort of transferable skills.
Yeah.
So I've got a little list that I'll share of ones that I came up with. I'm sure you've got a game pile in your house as well. Actually, we've got one of those sort of IKEA units, which is like a 4x4 cubed unit. And it's stacked with games. Yeah, so this is nowhere near what we've got. But so we really like Uno actually as a family game. My youngest is 6, and they can, really young children can start joining Uno, so it's a really nice family one actually. One of my favorites is Genius Square, which I'm pretty sure
we've got that.
I'm pretty sure I bought it because I saw Alice put up a photo of games you've got in your house, and we bought that one as one we didn't have, and I love it. So I've written card games. That's generic, isn't it? Any card game.
Any card games,
any card game. And then I've got sort of standard old style board games like Snakes and Ladders and Ludo. So then I've sort of put bracket dice, any game involving dice, really. I've stuck hide and seek in there, which isn't really a board game, is it? I must have gone on the line of thinking of counting. Hide and seek. Top Trumps is
you're comparing
in terms of comparing numbers and and quantities, different quantities, and measuring different and
fairly quickly, if they're interested in Top Trumps, is a good example because fairly quickly they get into fairly big numbers, and they because they whatever it is, whether they're into dinosaurs or superheroes or cars, because they're interested in that thing, the numbers kind of they can deal with it because they're interested in that thing. So really good.
Yeah, and then
sorry I interrupted you.
No, that's fine. I only had one more actually, but as I said, it's not, we could have just spent half an hour listing all our games. And then I put chess on there, which, as you were saying, that's not specifically a game, or it doesn't appear to be a game about maths. It doesn't, until you get into high-end chess, doesn't actually involve numbers as such. But it does, like you were saying, that it does have that, that cause and effect and that problem solving and that thinking ahead and logic. Loads of different skills in chess that are transferable into when we get into, problem solving, mathematical equations, as you were just explaining.
Yeah, and there's I mean, we're never really taught this, but there's a whole area of maths in game. I can't remember what it's called, but there is an area of maths on game and strategy, and like you said, like they're not like you're not tested at GCSE or SATs on a game like chess, but there are lots of transferable skills. So and especially decisions and strategizing is a skill that you need in life. So chess is a good one, really, to equip, because we're not, I think we have a very different philosophy when we decide to unschool, is that we are not doing it for our kids to pass a test. It might be one of the accidental outcomes, or it might be designed, but that's not our goal. Our goal is to make sure our kids are equipped for life, and they can win at life. So yeah, we're coming at it from a different angle, really. Games are essential, and pretty much any game that you think of will do that. But I like games where, like you mentioned Snakes and Ladders, and Snakes and Ladders is good for counting, but Snakes and Ladders is largely based on luck, and there's no decision making. Whereas games where children have to make decisions are really good, because they increase their understanding of lots of different things. So I mean, I can't think of off the top of my head, but Uno is a really good one, because you can play Uno to increase your advantage of winning.
Yeah, I mean, I'm gonna mention sort of computer games in there as well. One of my children has a really good understanding of numbers and is able to manipulate really high numbers because he plays computer games, because he has to work out, what items do I need to get so that I can get the right score, so that I can level up, or what combination of items, or what is the quickest way that I can level up, by which combination of moves that I have to do, or places I have to visit, in terms of what score I get for that. And how many gems do I need before I get enough diamonds, before I get enough pearls. And he actually spends a lot of time trying to actively figure that all out. How can I sort of manipulate this game so that I get to the next level in the easiest and quickest way. And my guys have all of my children love Minecraft, which is really interesting, because it's made them whizzes at like multiples of 8, because for some reason that I haven't researched or found out the answer to, the creators of Minecraft decided that when you collect things, that you would collect them in multiples of 8.
Yeah, so they're learning like base 8.
Yeah, like base 8.
Which is and so yeah, and again, I didn't realize that, but that's incredible as well, because all of a sudden they're operating not in base 10 that we're used to, but in base 8. So they become, again, that's really good for their mathematical thinking as well. And like you said, those computer games are good for quick recall. And quick recall is something they need because they're being tested on it. But actually, something else I want to add is that actually maths is not, real life maths problems don't take 2 minutes to solve, and they can sometimes they can take years. But so we give this idea to our children that maths has to be done really quickly, and no, it doesn't. I mean, I guess in schools that they want you to recall number facts fairly quickly and your times table fairly quickly, but beyond that, we've got calculators, so it's a question of, do you, okay, you know how to add and take away and multiply and divide, but do you know when to use these things? And we use calculators, so you don't need to be spending hours and hours and hours doing long division. I mean, why would you do that? It's like torture. I'm an advocate of slow maths and thinking through the process, and even thinking through a process without numbers initially is what I would do. So take away that, if you're working on a maths problem, take away the numbers and just figure out what's going on. Just work on maths without numbers and see how your thinking evolves.
That's a really interesting idea. I wonder what that looks like. Is that something I can press you on a little bit more to explain how that works practically?
Sometimes you get these kind of GCSE problems, I guess. About a tank filling up with water, and it's the water's coming out at, I don't know, a liter per second or whatever, and then how long does it take to fill the tank? So before you start to do that question, just take away the numbers and ask your children, well, how long is it going to take to fill the tank? And hopefully they'll say, well, how big's the tank? They're going to ask things like, how big is the tank? Or, well, that surely it depends on how quickly the water's flowing. And so they're thinking about the problem before we're putting any numbers in. So when we do put the numbers in, they're kind of primed to tackle that question. Do you see what I'm saying?
Yeah, I can understand. Yeah, I can understand that now. I think that was, I don't think that's something I've ever thought about before in terms of approaching, or maybe I've just not, maybe that is something that people do, but they don't realise they're doing it. You've just put words to, the process of how we do it. So I wondered if, we have this idea that sort of maths GCSE is like the pinnacle, because everybody, and I don't say this is truth, but everybody thinks that everybody needs a maths GCSE to enter adult life. So we have this, we hold it this aloft as the aim, we need to be aiming for a maths GCSE. And I wonder how you see children, young people acquiring enough mathematical knowledge and skills to enter the adult world, or to maybe even tackle a GCSE if they've never been taught formally. How do people that have never been taught formally, so you've mentioned that your older children are, one of them is currently studying for a GCSE at maths, how do they make that transition? How easy is it for them to go from not being formally taught and not sitting a formal maths exam to to acquiring that? I'm going to put the caveat on the end, if our children need to, or even when they want to. It doesn't have to be at the age of 16, they don't have to do it at the age of year 11. But if that's something that our children need for their chosen path into adulthood, or something that our children want to do, how easy has it been for your children to make that step into studying for that and acquiring the mathematical knowledge they need to be able to pass that exam?
For Eliza, it was very, very easy. He's naturally a problem solver, and he's kind of like an engineer. For Jo, who's our second son, it was slightly harder because he doesn't think as he's not a natural mathematician, so it takes a bit longer. But once you explain something to him, he kind of gets it, because he's, we've been talking a lot about play, and it's that foundation of play and relating it to things that so he gets it. But it took a bit longer, and he didn't pass his GCSE, or he didn't get a grade 5 first time round, and that was partly because in year 11 he didn't have a very good teacher. It just didn't help him. But then subsequently in the autumn he passed it because I just worked with him. Okay, they're lucky that they've got a maths teacher, but I wouldn't say that was the thing. I would say, provided that you have enough opportunities to for problem solving and discussing things, and not like I'm not teaching them like a method. We are discussing through a problem and talking through it. And someone that I've been reading a lot about is a lady called Jo Boaler. I don't know if you've ever come across her name.
Nope.
Jo as in J-O and Boaler, Boaler. So she's a British professor who has gone to Stanford University, and she's really an advocate of slow maths. She believes that you should have physical and tactile things for kids to work with, and rather than the teacher teaching something, children should be presented with a problem which is fairly meaty, but that they discuss together, and they spend a long time discussing this, and it develops their problem solving, it develops their communication, it develops their kind of reasoning, all these skills that you need for the 21st century. Before the teacher steps in and teaches, because the thing about teaching methods, again, is that you'll forget the method. Whereas if you are allowed time and space to talk to the people on your table and work as a group to solve a big problem, it's much more likely that you're going to understand a lot more and learn a lot more. So it's worth reading about Jo Boaler and her philosophy, because I think it's brilliant. And I've tried to have that approach as well in my maths lessons.
But I think it's interesting that when we artificially, because that's what we do when we put children in school, we put them in an artificial environment.
Yeah.
And from what you were saying about this lady, providing them with these meaty problems that they then have the opportunity to work through together and discuss and try out ideas, and with physical concrete resources in front of them. When our children are living their everyday lives in the real world, that's effectively what they are given in the real world. They are given real world problems, real life problems,
exactly,
in their day to day, and they are surrounded by, if they're with their friends or their family, they're surrounded by people that they can then go through that process with. But it's in a real world situation instead of,
and it's not, that's right, and most of the maths that we do is not. It's not a question of right or wrong. It's like their decisions, a series of decisions that we have to make. So an example of this is we've recently decorated our front lounge. Now, it's not just about, there's a lot of mathematics because you have to work out the area of the floor, how much carpet you need. Well, carpet doesn't come in that size. It comes in rolls. So you got to do the maths for that. Then you got to work out how much paint coverage there is, and you're kind of like, sometimes you're measuring, sometimes you're not measuring. You're kind of going, well, that was about 5 meters across, 2 or 3 meters up, and you get a rough idea of the area of the walls. So you you're doing maths all the time. You're making decisions, and or whether you're tiling your bathroom or whatever it is, these are real math problems.
We've recently done similar. In fact, to most of our house, we're in the process of decorating and carpeting and flooring and wallpapering different parts of our house. And I think the thing that I really want to pull out of this of this part of our discussion is that I have rooms in my house that are half wallpapered at the moment because we haven't got the answer right. You know, if it was a GCSE question, I would have got the answer wrong. Or there's been walls that we've painted and then we've gone, oh, hang on a minute, we've run out of paint, and we've had to go back to the shop and buy more paint because we've got the answer wrong. And one of the things that we are taught in schools is that maths has a correct answer. There's a right answer and there's a wrong answer. And that is, I think, contributes to this idea that we can't do it, and that it's difficult. And actually, in my life, in the real world, I have made mathematical errors, hence why some of my rooms are only half wallpapered. But the consequences of that haven't actually been, you know, I've got a half wallpapered room. It's not detrimental. Like, I just go and buy more wallpaper. It doesn't have the same feeling of like devastating consequences because I have got a big red X by that. I failed. Well, I got it wrong. It wasn't a massive. It's not a massive
and it's
problem.
And it's kind of like, you know, when a baby or toddler's learning to walk, and they're going to fall, aren't they? That's part of their process, right? And it's the same with your wallpaper situation. It's like you do make mistakes, but that's how you learn. Those errors are actually precisely you need to make the mistakes. Finding it difficult makes your brain grow. I think mistakes are part of the process. So when you're teaching, you're kind of shortcutting that process. You've got to make that mistake for you to learn, actually, I didn't make enough. So you might go away next time and think, actually, I better learn. I better actually work out the area of this wall, because you don't want to make the same mistake again, you know. And it wasn't, no biggie, because you can just buy more wallpaper, can't you, at the end of the day? You know, when you make a mistake at school, why are you made to feel so bad about the mistake? Like, is it a big deal? No,
it's part of the learning.
Part of the process, right?
Yeah.
You know, collaborative learning should be discussion about a math problem together is much better than someone teaching you a method of how to do it, because you'll learn so much more, and you'll learn this because problems don't come with formulae. You've got to formulae are useful, but you've got to think about the problem. And unfortunately, most people think that in maths you have to learn a lot of formulae. Well, actually, you don't really.
I wanted to ask a question that lots of people discuss in home educating groups and on unschooling groups, and it's sort of indicative of how important, well, the question is, how important is trigonometry, right? And I don't think it's really specifically asking about trigonometry as such. I think the question is, how important is it for us to know all those different, how important really are they at I've put at the age of 14. So, when children begin studying them in terms of for their GCSEs, how are they relatable to life? So we've already alluded to, like, why aren't they taught financial
exactly
things, things that are actually useful for life and life
skills, which are most useful to most of us. In order to answer the question right, apart from in the classroom, I don't think I've ever used trigonometry in my real life. Now, if I was maybe an engineer or an architect, I might need it. But in my day-to-day life, no, it's not important. And so many other things are not important. Like, I don't need to know how to solve simultaneous equations in my daily life. They just aren't important. But what is important is, the ability to think through a problem and solve it. That is a skill that you need in life, whatever it is, the problems occur in life, financial problems occur in life, and you need to figure out a way to solve those problems. So no, trigonometry is not important. Just as, if you didn't learn Shakespeare, no one's gonna, who cares? Shakespeare is good, but at the end of the day, it's inconsequential, but you might need to know how to write a CV or something like that. That's maybe more important. And even that, I would say, is kind of a dying thing, because now people are doing video CVs, or they're building websites about their profile, and they're going onto LinkedIn. So I don't know. The world is changing so fast that what are the skills that you need for our 21st century? Problem solving, critical thinking, creativity, collaboration, communication are the key skills you need for our 21st century. But trigonometry is very low on my list. And simultaneous equations, like, who cares? So what I'm someone who says, well, they're good, like all those skills about deduction and things like that. That's why I go back to play the games, because you understand, if you know how to do deduction, you'll be able to solve simultaneous equations. But you're only doing it to pass an exam.
Yeah, I think it becomes like most other things, in that when there's a need to do it, our children will be motivated to do it because they need the qualification. So then they'll do what they have to do to get that qualification. But that's a brilliant way of actually wrapping up what we've been talking about, because it really brought together all the things that you've been talking about in terms of the key skills that children need to be able to operate sort of mathematically, to understand maths, and all those skills that they are able to gain through their everyday living, and through playing, and things that they choose to do, and how that is it's completely different to the way that we were taught, and that we understand, or that we have understood how how maths operates.
Personally, I think mathematics is a beautiful subject, in that when you see the patterns in nature, the number of petals on a flower, or a honeycomb, or a snail shell, actually they're mathematical. They are mathematical. And when you see a tree, it is a mathematical fractal. And there's this whole area of maths, the beauty and the patterns in nature, and mathematics is all around us, but we never really learn how to appreciate maths like it's a thing of beauty, and it links into art and science in such a profound way. And I think if children were taught more of that, I think they would learn to enjoy it as well, because it's not just about numbers. It's not. I mean, I know our society operates in numbers, but there's a whole lot more to it. It's a way of thinking and looking at the world and thinking about the world. It's not just about numbers. So
yeah, I put down on my list of things actually art. My daughter is really creative and loves art. A lot of the things, she often goes through times where things are very geometrically sort of accurate in what she's drawing. And I think once we, like you say, it relates to science as well. Once we begin to see that all these things are linked and connected together, then it adds to our, and like you were saying earlier, our understanding of how maths works and how maths is essential to our everyday life without us really being aware of it always.
Yeah. You know, I'm just reflecting back on my childhood, and in my room we had this disgusting 70s wallpaper, but it was a brown wallpaper with different flowers, and I used to spend ages staring at this wallpaper and trying to figure out the patterns. So to me, just patterns are interesting. There's nothing. Patterns are mathematical, but I think, you know, just staring at the wallpaper, and it sounds really boring, but I was just trying to figure out patterns in the wallpaper, and that is what mathematics is about. Patterns are interesting, and drawing patterns are interesting, and drawing fractals are really interesting, and the fact that a snail shell is based on a mathematical I can't remember what it's called, but it's based on the Fibonacci numbers and the golden ratio. I think it's just fascinating, and the fact that the beauty that we see around us, a lot of it's based on the golden ratio as well, and Fibonacci numbers, and so it's just interesting. It's just interesting. So, you know, that's what we really want our children to be, really curious and think, why is that like that, and why is that symmetrical, and how does that work? And that's all, that curiosity, rather than, you know, I think our curiosity is again interrupted by someone telling us what the thing is. Oh, here's the answer. Teacher's the expert in the front of the room. Well, actually, you know, one day I don't want the teacher to be the expert, because he just stole my joy of discovering it for myself. And so I think, you know, if we can kind of encourage our kids to discover things for themselves, rather than giving them the answer straight away, or this is how we do it, they might come up with a completely different way of doing things that we'd never thought about. And I don't think we always have to have the answers either. And if we were rubbish at math, then it's time to learn and try and enjoy it, and try and solve problems again without the baggage of, do I need to know this formula? Or
when you talk about adults trying to find their own joy in it again, it's about tipping upside down what we've been told, which is that you had to learn this formula and you had to find the right answer, and actually beginning to look at the world from a different perspective, and from that standpoint of being curious and asking our own questions, and saying this is interesting, or, you know, this, or even, you know, maybe I need to learn this for a practical reason, and coming at it from a different that different perspective of our own curiosity, our own sort of, like you say, that looking at something and going, wow, that's really beautiful, that's interesting, that's you know, how does that work, and starting off from that point, sort of almost doing what we want our children to be doing, actually asking their own questions, and being that, like I mentioned at the beginning, which is where we started, being that active participant in the journey, instead of feeling like we have to be told what to do, and we don't understand it, and we've got the answers wrong, and that just makes us feel worse. So being that active participant in the journey, following our own curiosity, giving things a go and not worrying if we get it wrong.
Exactly, giving things a go and not worrying you're going to get it wrong is the way you're going to learn. And, you know, I always say, well, you know, try it, give it a go, see what happens. And that's it, you know, that giving them the security that actually it's not a big deal if you get it wrong. You'll find out fairly quickly when you're going wrong. It should be more of a discussion really about the problem, rather than going to a right or wrong.
I wonder if it would, if people would feel more confident if, like we were saying earlier, if they were able to write it down on a piece of paper or get items out that are going to help them to solve the problem, concrete physical items that are going to help them solve the problem. Because like you were saying earlier, one of the things we are actually taught in school is that we need to memorize this and we need to figure it all out in our head. And quite often, I mean, I don't know where things stand now, but quite often in exams you're not allowed to take a calculator in, which, as you've pointed out, is ridiculous.
It's ridiculous
in today's world, because we have calculators.
Now, I think at least the exams are slightly improving. So most GCSEs now, one of the papers is non-calculator and 2 of them are calculator, which is only right. But in my opinion, the whole thing should be calculated. We shouldn't be testing what I call something that a calculator can do. But you still have to know how to use the calculator, and you still have to know what buttons to press. So it's more, kids do have to have an understanding of number and so on. But once they know how to add, do we have to flog it? Just get the calculator out. It's
I wonder if that's one of the things that we worry about, that if we allow our children to rely on play, rely on concrete items, rely on a calculator, that we're doing them a disservice.
No,
actually we're not. We're doing
because in the real world, scientists are always modeling things, and it's just modeling something, right? So I'm always telling, certainly I tell the kids that I'm tutoring or teaching, let's draw a picture, or let's get some props to help us figure it out. And then you've got to do it, because it kind of it might be the sort of catalyst for them to solve that problem, because they see something tangible and then something kind of clicks. So even when I solve a problem, I'm drawing pictures. What's wrong with that? I have to do it as an adult. I'm not doing it all, a lot of it I am doing in my head, but I'm doing a lot. Even if I'm not drawing it, I've got pictures in my head. So why not? What's the big deal? I mean, it could mean that you unlock something that you didn't really understand. And so you have to go through that process of drawing and playing and getting props out. Whether they're teddy bears, it's not babyish, it's just a way of solving a problem. Get your Lego. Who cares?
Fabulous. Yes. Well, once again, I feel like we've done unschooling proud, and we've sort of highlighted how beneficial it is, a way of our children living and learning naturally, and that they will grow hopefully into confident mathematicians who are able to navigate the world around them, and just as importantly, they learn how to learn. They learn how to do things.
Learning how to learn is
key. And if they get to adulthood and they come across something they don't know, it won't be something to be ashamed or be embarrassed about. It will just be something else that they will then apply themselves to find out. Well, we're gonna wrap up our conversation there, and I'm gonna thank you for taking the time to come and share your knowledge about maths and how people learn maths, and how that applies to us as unschooling families. It's been really interesting and particularly helpful. And so I thank you for coming and joining me this evening. I just remind listeners that Alice has her own Facebook page, actually, at Organic Education, which I will put in the show notes. I'll put a link into the show notes. And I know that you occasionally join her there, and you discuss unschooling and encourage people there on their journeys too. And listeners can join me next month. So thank you for joining me, Krish.
Thank you for having me.